let's learn how to calculate a few different types of energy. There are three that are particularly useful and quite straightforward. There's gravitational, kinetic, and elastic. So let's have a look at how to calculate the amount of energy involved when we're dealing with these three types of energy. We're going to start off with gravitational. So let's have a think about some things that might affect how much gravitational potential energy something has. Well, we've already talked about before how the higher up something is, the more gravitational potential energy it has. So its height must be one of the factors. You could also probably come to the conclusion that it's going to take more energy to lift something that's heavier than it is to lift something that's lighter. So that means the mass of the object must also influence how much gravitational potential energy it has. And the reason for this whole thing existing is gravity, the gravitational field of something, and how strong that gravitational field is also going to affect how much energy that the object has. And it turns out that it's actually just these three things multiplied together. Height multiplied by mass multiplied by gravitational field strength gives you the gravitational potential energy. And just for reference, the gravitational field strength down here on Earth, near the surface, is 9.8 newtons per kilogram. Okay, so what about kinetic energy? Well, kinetic energy is to do with moving. So the faster something is moving, the more kinetic energy it is going to have. And we can use the same argument again. It's going to take more energy to accelerate something heavier than it is to accelerate something lighter. So that means the mass is probably going to influence how much kinetic energy a moving object has as well. Now, this equation is a little bit more complicated than the one we had before. The equation for kinetic energy looks like this. It's half times mass times velocity squared. And finally, what about elastic potential? Well, I know that when I'm stretching something, I'm storing elastic potential energy in it. And how much I'm stretching it by is going to influence how much energy is stored in that thing. So the amount that I've stretched it by, the extension, how much bigger or smaller that thing has gotten, the change in length, that's going to be the main thing that affects the elastic potential energy. And another thing that affects the elastic potential energy is something called the spring constant. The spring constant is just a number for anything that's stretchy, and it just describes basically how stiff or how stretchy that thing is. And the equation for elastic potential energy looks weirdly similar to the equation for kinetic energy, but this time we've got half times the spring constant times the extension squared. Okay, so there you go, three really important equations to work out gravitational potential energy, kinetic energy, and elastic potential energy. Now go and check out my video where I do a worked example question that makes use of all three of these equations.